We good now? You sure?
Yeah.
Okay, cool. Yay! Hello, everybody, and welcome to Isaac Jackson. Woo! I'm gonna throw something at you. Tonight we have Mr. Worldwide, Isaac Dunham, with everyday data analytics for IT and cybersecurity. And he's gonna be loud tonight.
Yeah.
Woo!
It's gonna be great. Cool. All ready to rock and roll? All right, let's get rocking and rolling. Ready to rumble. Uh, Hello, everybody. Today I'll be giving a little bit of a presentation on everyday data analytics for IT and cybersecurity purposes. Uh, First, we're going to start with the most important slide, which is me. Most people in this room know who I am at this point, but a quick recap. Picture of me as a small child sitting in a dishwasher. Um, it hasn't really gone that much better since. It's mostly gone downhill. But currently work as an incident response analyst over at Consumers Energy. I've been at Consumers Energy for about 6.5 years. I've worked in security operations, IT, legal, and incident response, all while do I was an intern at various times and going through getting my degree from Eastern Michigan University. And I've been in my current full-time role for about a year at this point. Had my year celebration very recently. It was wonderful. I said it was the longest year of my life because they would only give me a 1 year service anniversary, despite the fact I've been there like 6.5. So that's how that works. So we'll hop right into it. Today we're gonna be talking about data analytics. So first we've got to figure out, what do I mean when I say data analytics? Um, if you talk to different people with different levels of intensity, you're going to get different definitions of data analytics. I'm sort of a smooth sailor. I'm sort of chill on the definition of data analytics. To me, data analytics is just using data to make decisions and tell a story. That is how I define data. Some people will say, well, it's only data analytics if you're doing crazy complicated math. I think math is always a part of it. I think statistical properties are always a part of it, but it's often the simplest things that tell the best stories. So that's what I treat as data analytics. Some of the use cases I have on the screen there include, from an IT and security perspective, you can use this always. You track team/system performance, tracking your metrics, tracking your SLAs, stuff like that, identifying and troubleshooting issues. Oftentimes, issues in systems are only one little log message away from figuring out what's wrong with them. You just have to go hunt for them. And then third example I'll talk about is threat hunting. In my view, threat hunting in an incident response perspective is basically just an exercise in very security focused data analytics. It's trying to find the anomaly, it's trying to find the evil uh, that exists within your data, assuming that you have that data. So that's what I define data analytics as. Common data sources that we have in the IT and security realms. You can chunk this up into a number of different ways for this beautiful presentation. And on this beautiful slide, I've decided to chunk it into endpoint, network, uh, documentation kind of systems, automated inventories, internal systems that collect info, scanners, that kind of stuff. And then online threat intelligence, feeds and sources, stuff like that. Those are the most common data sources you deal with. So on your endpoint, you have your system logs. Think of your Windows events, your Linux syslog, uh, your network devices. We'll think about our firewall logs. We'll think about our proxy logs. We'll think about, if you're tracking them, your switch logs for whatever reason. Um, Different network devices. Your CMDB, your configuration management database, which should hopefully include an accurate asset inventory. I think we've not yet fully figured out that concept, but it should probably be one of the most valuable sources of data you have in your organization. Um, it should always be referenceable and easy to use. Uh, Threat intel feeds, threat intel sources, data indicator sources, they all exist. They come in many different forms. Some famous examples include DShield's blacklist or Spamhouse's list of 10 quadrillion horrible sites that ought not exist. stuff like that. I have a friend who he was doing some contract work for a legal firm. They weren't able to access the internet, and what had ended up happening was there was I think it was the Mirai botnet or something was on their edge router at their office. So Spamhaus had put their information on block lists, and they had to figure that out before they could resume business. So that's fun. Interacting with data day to day. You have different tools for different use cases. I think the most broad use case you have for data for organization-wide stuff would be dashboards telling stories of things that are happening in an organization. Uh, some of the coolest dashboard tools that exist out in the world are Microsoft Power BI. I'm a big fan of that one. But other friends that exist are Grafana, Tableau. Lots of different vendors there. And when you're doing in the moment raw data processing, there's a bazillion different tools that you could be using, but the Swiss Army knife that won't die is Excel. It can just do everything. I remember I was at a SANS training recently, and we were doing a Net Wars event, and everyone was trying to do command line kung fu, which I was not very good at the time, to look at this raw log file and find the exact data that they were looking for with sed and awk and stuff. And I just wasn't good at that at the time. Probably still not very good. But that data also existed in a Kibana instance. And I just exported the CSV, opened it up in Microsoft Excel, found what I was looking for, and I was able to get the question answered. So Swiss Army knife that won't die. A really cool thing that's happening with the modern SIM is they're becoming more and more like data processing tools, things that you can do analytics within that system instead of just a place to go find the logs. So that's fun. Some of them support visualization options in line. So if you're familiar with the Elk stack, for example, the Elastic stack, you run your SIM query, you find the logs of interest, and then if you want to make a graph or something, you got to go click on the visualize button. Then you got to go say, I want to aggregate by this and aggregate on this. And then I want to select this. And I want the top. It's a whole bunch of clicks just to get like a little pie graph or something. Whereas products like Microsoft Sentinel now, you can just do render pie chart. You have a pie chart. It's great. Quick discussion on parsing and parsers, particularly in the world of incident response, security operations, day-to-day ingestion of security events, and review of logs. Parsing is a very cumbersome and difficult task. It can be very miserable and time-consuming, especially with how horrible some vendors are about coming up with the worst possible schemas for logs that exist. Cisco devices in particular are just some of the worst things ever for parsing, where it's like, who came up with this format? Every single different type of log has different fields and different locations. And if you look at the official parsers that people actually go make for those things, it's basically just 500 if statements of if log looks like this, then this field is here. If it looks a little bit like that, that field is actually there this time. So it's a very cumbersome process, but I find it to be very necessary, especially in the moment and day-to-day operations. And if you're doing stuff like threat hunting. My recommendation on parsing, do it and do as little of it yourself as you can. There are people that get paid money to do nothing but write parsers all day. So go look on GitHub for parser for X product. And hopefully, probably, usually someone has written something for it. It's important. Okay, now we're going to go into some common statistical properties that I deal with on a day-to-day basis in the realm of threat hunting and cybersecurity incident response. But really, these are statistics everyone deals with everywhere. The simplest aggregation statistical property you can get of anything ever is just a count of stuff. We had this many Windows events occur, get forwarded into our log forwarding system. Very simple. Average and mean, we know these things. Median, this is like average, but better in my view. It's less susceptible to outliers. So I like median. And then standard deviation is probably the most common or the most complicated of the simple statistics that you can find lying around, but it's very useful for trying to find statistical abnormalities. So the way standard deviation works is if something is in a normal distribution, a bell curve, a set of data is in a normal distribution, any point of data is 95%-ish likely to lie within two standard deviations of that. And if something falls outside of that, it could be interesting. So that's a good way to identify statistical anomalies. Now, going a little bit deeper, here I have three layers of data analytics of interacting with different variables. So you can call this multivariate aggregation and temporal analysis, which is a fun way of saying this, but it's just stuff based on other things over time is all I'm saying here. So in the lower left of the screen, I have a very simple example. We're looking at Windows Event ID uh, for specific Windows Event IDs, logs that have come in over a 6-day period at some time in the past. We get a count. It's a really big number. I'm not good at telling at a glance what a big number is. I just know that's a pretty big number. So that doesn't really tell us a story. That tells us, well, we get a lot of logs, but what is a lot? It's all relative. Now, if you start to aggregate that on other things, you add a new variable to the problem. You can say, hey, I want to get a count of the logs that we get, but base it on the event ID of those logs, the event ID of those Windows logs. And then we have a bit more of a story going on. We can say, hey, we didn't just get 2 quadrillion bazillion logs, right? We got that many logs, but the vast, vast majority of them, looks like half, were PowerShell module logging logs and account logon logs. So that tells us what are the noisiest log sources in the environment. And then if you add a third variable to this situation, you start to, which is grouping these counts by 1 hour timeframes, you start to be able to tell an even more interesting story. You start to get count, and then you have time, which you can use as your x-axis, and then you can now create a line graph for all of these different event IDs that exist, and now you can tell a story of what logs are coming into your environment and what that means. So the little example I have in the lower right, little hard to read, but basically what we can see is event ID 4103 is this dark blue line. It has big spikes occurring. And they're occurring at roughly 11 a.m. every day on these certain days. The question that might come up is why is that happening? Is that normal? Is that abnormal? Is that driving our billing costs up for storage? These sorts of things. So just adding dimensions, you can tell more and more interesting stories. A fun security-based example that's not just operational or log health related is some attack types that you see are actually most easily detectable by this sort of data aggregation. I was witness to an exercise wherein someone engaged in Kerber roasting on Kerber roastable service principal names in the environment, right? Or attempts to. And when you're looking for this, it's initially very, very hard because you get told, okay, look at event ID 4769. This is Kerberos stuff. You take a look at that. It is such a voluminous, loud log source that even getting 10 minutes of those logs will bring searches to a crawl. It's very hard to parse. It's way too much data. You filter it down to, I found a trusted sec article that went a bit more into detail on how you can identify this type of behavior. And basically, I did a bunch of filtering, and even that was still too noisy. So what I started to do was I started to aggregate based on different properties. And the properties of interest in this case were the username, which is the account that was doing the evil activity, and the service name, the service principal name that was being acted upon. And when we looked at a count based on the number of interactions that happened there, we saw something that was more usable, but it was filled with a lot of service accounts, basic Kerberos operations, really not very interesting stuff. We would see, say, the service account interacted with this SPN 45 times. But when you think about if someone's performing Kerberosing, this activity, there's no reason they would be interacting with the same SPN a bazillion different times, right? That's just how this activity works. So I found, well, let's just filter out all these noisy ones and say, now give me a count based on who has the most distinct relationships with other SPNs, with other service principal names. And this data jumped out like an absolute sore thumb, something that was completely unparsable, unusable, felt undetectable, was now obvious. I have a little table in the lower right, which is this e-hacker account. Had 140 of these sorts of relationships with different SPNs. And that's very obvious. And there's very little good reason for it. So that's how statistical analysis and aggregations and digging deep into data can help you find things. Threat hunting activity. So we went a little bit into common, fun statistical properties, but there are some special ones as well. These are a little bit less useful in a day-to-day and a data analytics perspective. These are rarely things you're going to find in a database lying around, but it's showing that math and statistical analysis are important. So there is such a thing in the world as entropy. Entropy is basically a measurement of how random is something, how mathematically random and unpredictable is something. This is noteworthy because when you look at an encrypted piece of data, the idea behind encrypted data is that there's no pattern to it. If there was a pattern to it, that means there's a flaw in the encryption scheme that could probably lead to someone eventually being able to decrypt it. The desired outcome of encryption is something that's just completely indecipherable, no pattern, no meaning to it. So when we take this measurement of how random something is, encryption is extremely random, and we apply this measurement to something like a program file. Think a calculator.exe on your computer, calc.exe. This is a binary program, but it's not random. There's no reason that would be random. There's very few reasons, there are some, but there are very few reasons a program would be random. But what we know from malware is that attackers, because they don't want to be detected by antivirus or endpoint detection and response solutions, is they will encrypt their payloads. They'll encrypt their malicious payloads such that they won't be detected. So what you end up having is a program that has a very significant amount of encrypted data in it. And if you went and you measured the entropy of a program like this, its entropy score is going to be way higher than a normal program. So this little example I have here, I created a little piece of malware sample that was using a calc.exe payload. Basically, calc.exe would pop open when the malware ran, and I encrypted it using AES, and I output the EXEs. What I have on the screen, I'm using the sysinternal sigcheck tool against two programs, a normal system binary, and it comes with an entropy score of 3.9. Not a very high number, but when I run it against my evil malware sample, the entropy is 7.4. This is a significantly higher amount of entropy, and general consensus is if you find entropy that's above 8, that's very interesting. So that's an interesting, fun statistical property that has a fun use case in malware analysis, for example.
Question.
Yeah.
The encrypted hard drives up back to baseline program like calc.exe.
Say the first part again. Some encrypted hard drives.
Encrypted logic hard drive.
Yeah.
Get the base programs like that.
Yeah, so I think while an operating system is running, the contents are decrypted. They're not encrypted at runtime. But you turn it off, you log out, then those contents will be encrypted and unusable. And they would show higher entropy scores, but it would also be very hard to find them in general. So, yeah, that's my response, if that helps. I hope so. There you go. Yeah. Another fun little statistical property that exists in the world is frequency analysis of letter combinations. So a problem that used to be more prevalent, it's less prevalent now, is you'd have domain generation algorithms, which is you have a piece of malware and it needs to reach out to a command and control server out on the internet. But infrastructure is very easily blocked. We find out that a piece of malware is talking to evil.com. We just block all traffic to evil.com. Problem solved. So what malware started doing is they would have predetermined seeds put in them, which would help them determine a predetermined list of random domain names. And these would take the form of stuff like .com and .com, complete gibberish, right? Nonsensical sequences of letters. The example I have on the screen is also incomprehensible, but it's waboo.net, right? And something that you can do, and this is a task that Mark Baggett at the SANS Institute took on. He said, well, if we can establish a mathematical baseline of what are common relationships between letters and their order and their likelihood of appearing next to each other, we can calculate a score of how probable this sequence of characters together is. And for a while, this frequency analysis was actually built into the Security Onion platform, as I recall. Um, since then, a lot of this sort of behavior is more easily detected. So attackers now have migrated on to, instead of using random gibberish as their domain names, they'll use random sequences of real words that kind of bypasses this statistical analysis. So ever-changing landscape, we come up with a cool idea, it gets ruined. Tale as old as time, but it's fun. Now I'm going to go into some common security data anomalies that I run into while I'm doing threat hunting activity in my role. These examples are taken from a course that you can find online on the website networkdefense.io. This course is authored by a really great guy, Chris Sanders. And this course goes over from A to Z how to do threat hunting, not just technically, but also logically, analytically, thinkingly. I don't think that's a word. And these are three examples taken from common data security anomalies that happen there. So the most common form of anomaly that you will see in security data is probably going to be an uncommon frequency of occurrences of something. This goes back a long ways. We think to some of the earliest security recommendations you can find lying around, and it's keep an eye out for a very high number of account login failures because it might indicate a brute force attack. This would be a frequency of occurrence anomaly, right? Improper timing. This is another anomaly type. This is a fun one in the exercise of baselining. Figure out when things are supposed to happen, and then you can take a look and figure out when are they not supposed to happen? When is that not common? A little use case I'll dive into later for that is think about multi-factor authentication prompts. If your company uses multi-factor authentication, they might have it come in as a notification on their phone, a push notification, or they have to enter a code or something. But what happens if you get a notification prompt at 2 a.m. while you're asleep? A lot of these multi-factor authentication services, they have a button that says, oh, this wasn't me, I can report it as evil. But if you're asleep and you never know that that prompt came in the first place, that means we know someone has your account credentials and is trying to log in as you. And now they might be able to try to leverage those account credentials, particularly if you reuse your password, elsewhere that might not be protected by multi-factor authentication. So if you can establish a baseline of, I expect my users to be awake at this time and asleep at this time, and then you look at multi-factor authentication prompts for when you expect people to be asleep, you get a very small list of activity, mostly people that are working way later than they should. And then third common security data anomaly that is fun is unexpected entity relationships. This can also be a fun exercise in the practice of baselining, but let's consider the example of a web shell. What often happens in a web shell attack is the web server process responsible for keeping the web server going will get hijacked and start doing bad things. People will do things in the context of the web server process. So you can take a look and see, what is the web server process? I have an example there of w3wp.exe. That is the IIS web server process. And we can take a look and see what child processes has that made. Has it made cmd.exe? That's more common than you think. But did that cmd.exe then make whoami.exe to try to figure out what account it's running as, what privileges it has? That is very uncommon. That's very rare. So that's an example of an unexpected entity relationship. You do not expect whoami.exe to be associated with your web server process. So now we're going to go into some kind of practical examples of how you would actually go about finding these things in different tools. I am most familiar with the Elastic Stack, and both Microsoft Sentinel and I think at this point QRadar use Kusto query language, which is fun. So if you're in the Elastic Stack, you can do a frequency of occurrences kind of example by first filtering down to the data you're interested in, clicking this visualize button, doing an aggregation based on count, and then doing an aggregation based on terms for the buckets as opposed to the metrics, and then grab the field that you're interested in. In this case, I just grabbed process name, new process name. What are rare processes being executed in the environment? Because if a program is being executed, it's probably being executed broadly and widely. So that's a way you can find rare process executions from within Kibana. You can also do this at the command line. I've gotten slightly better at command line Kung Fu, but not by much. But command line Kung Fu tools include cat, grep, awk, sed, and JQ. JQ is a tool I've recently learned about, where if you're dealing with text data that is in a JSON format, you can use JQ to pretty easily grab fields that you're interested in and convert things like date and time to more human-friendly formats. And then the most dangerous weapon in the world of command line Kung Fu is a combination of sort, unique-c, and then sort-nr. What this is doing is it's sorting all of the data that you get. So you get a text file that's a bunch of IP addresses. It will now sort them. Unique-c will take those sorted fields and it will get a count of all of the individual IP addresses that showed up. So now you can see this IP address showed up 1,000 times and that one showed up once. And then if you do sort-nr, that will sort it in reverse order so that at the bottom of your screen, right after your terminal line, right above your terminal line, you'll see the rarest stuff first. So the example I have here is what appears to be a task scheduler creation. It's called Offic Updater, and it's running a program in appdata local/temp/ called update.exe. Doesn't sound particularly legitimate. Maybe it is, but definitely worth looking into. Definitely anomalous. Here's an example of improper timing using Microsoft Sentinel, KQL. This is some pseudo language. It's pretty easy language to pick up once you've dug into it with enough time. I guess that's true of anything. But you grab your MFA logs, you do some filtering, you say, I want Eastern time to be this timestamp converted this way. I want to grab the hour of the day, and then I want to filter my hour of the day to between 11 p.m. and 4 a.m. And then you can see multi-factor authentication prompts of interest. So in this case, we see I'm Dunham at 1 a.m. Sounds legit. We say J Rico, Johnny Rico. He's at 3 a.m. in Buenos Aires, Argentina. That's weird. GW Lucas at 11:30 p.m. in New Mexico, but George Lucas lives in California. This is impossible. So, kinds of analysis that you can do there. And then here is the unexpected entity relationships. Again, using Microsoft Sentinel. In this case, you can do process events where the parent image is this particular thing. Image in this case is just referring to an executable name, w3wp.exe, and then we'll do a count of the actual executable file that it has emerged, and we can see what are the rarest ones. In this case, we see background underscore process.exe was spawned a very small number of times, and I've never heard of that thing. And that's how you can find this sort of data anomaly. So, chugging along, we're going to do maybe more math. This math is normalization. It's a useful way that you can rescale data to fit a particular range. So this will come up useful in an example where I'm going to talk about log source management, which is a horrible nightmare that the world has not yet figured out, but we're getting there. Basically, with normalization, you can take data that has very different scales. This data is all 1,000 times bigger than this data. If you divide it all by its mean, this is called mean normalization. This is a very simple way of lowering things to a common scale. You can make everything operate on kind of the same playing field of everything should revolve around the number 1. Okay. So what that allows you to do, this is more stupid KQL stuff, but just showing that you can do it if you wanted to create a dashboard. Mathematically go grab the average and then extend normalized data as the count divided by that average. And this is what it looks like. This is a graph that's showing our data sources, example data sources, that is completely unnormalized. This is hard to read, and it doesn't really tell a good story of what's happening. Everything's kind of, we can see that the top blue line, which is the firewall vendor in this case, is very clearly significantly more loud. There's more events happening for that than anything else, but I don't really know the story for any of the other lines. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't do math when doing a presentation, but I count 9 different lines that we're looking at, but I really only see 3. The scale of the bottom ones is so small that it's just unusable. But now, if you normalize all of those lines, we have a story that we can tell about our data source health that is completely unreflected in the data we had previously, in the graph we had previously. Here, we can see the load balancer vendor had a massive influx of data occurring on June 25th. Why would that happen? Okay. And it would be more easy to see if a log source completely went to 0 because everything is sort of operating on a more standard scale. So you get a much better story when you're operating with normalized data in this case. That's fun. You can write and talk about, and people have, a great number of things for a very long time. Metrics. Metrics are fun. Metrics are horrible. Metrics are evil. There's a famous quote, which is, all models are wrong, but some are useful. I think that's talking about economics. My opinion is that all metrics are wrong, but some are useful. And you have to think about these kinds of things that you calculate and grab from a data perspective. And if you're going to track them, and if you're going to measure them, and if you're going to put them on a blinky board in front of executives or something, you need to think about the ramifications of what's going to happen. You need to think about everything in terms of pros and cons. So probably everyone is familiar with the problem of we have an SLA, a service level agreement that says our time to resolve this issue needs to be low. What ends up happening a lot of the time is this service level agreement time inches closer and closer, and the issue is not resolved. But the person that is working on this investigation, is working on this ticket, is doing this work, they feel pressured to maintain that SLA. So what they're going to do is they're going to close out that ticket prematurely without doing everything they ought to. So pro, you encourage speedy work. Con, the work quality probably is going to suffer. So as you implement metrics and as you track them using all the math in the world, try to balance these pros and cons out with each other and try to be very mindful of how they affect things. Continuing to rag on metrics, some recommendations I have in the world. There's a quote from Carson Zimmerman, who was the original author of MITRE's 11 Strategies of a World-Class SOC, also co-author of subsequent release is plural, I believe. And he says, you should not be involving hand-genning of spreadsheets in any form or fashion when it comes to metrics. I extrapolate that statement to say all metrics should be automated. If they're not automated, I don't like them. That's my opinion. That's my violent, aggressive, fury-filled opinion on metrics. And again, reiterating, be wary of unintended consequences when it comes to these metrics. Here's a good use case for metrics and dashboards. And I see this I've heard of this happening in a number of different places, and I'm personally familiar with it, which is vulnerability management dashboards are cool. Do we have people that do vulnerability management in the room? Do you have dashboards?
Yeah.
Do you like them? You can dispute them. Oh, everyone hates them. Do they help a little bit? Okay, they help a little bit. We have lukewarm reception. If they work, they would be helpful. Yes. Yeah, maintaining dashboards is
I just love it though. They're pretty.
yeah, there you go. Having the vendor provided ones is sometimes all that you can do. But a common case I see happening in the world of vulnerability management is you have a lot of different platforms that are trying to gather patch or compliance information on different sources of systems. And all these things are disparate. But what you can do is you can use API queries to reach out to all of these sources of compliance and patch and vulnerability information, aggregate all that data together in one location, and then you can use a dashboarding tool, something like Power BI or something like this, and you can create a dashboard that says, hey, here's the number of vulnerabilities that actually exist in our environment. And if you have even better data, you can start breaking this down by business unit. Hey, the IT organization, they have way more vulnerabilities than the security organization. Who'd have thunk it, right? And if you have these things visible at an executive level, you should indeed be aware of unintended consequences, but you can also leverage this to, in a friendly competition way, help remediate vulnerabilities that are never ending and everlasting. So that's a fun case. When people hear data analytics, a lot of people want to talk about machine learning. I have a little bit of experience in this space. There's pretty good use cases for it. I think the biggest issue that crops up with machine learning, in my experience, is amount of investment required to get good outcomes from it. That is a very high number, but there's a lot of fun use cases that you can look at. The first example I have there is malware triage. Earlier this year, SANS put on an event called Secure Your Fortress, where they had a number of people from their cyber defense curriculum come give fun talks. And David Holzer, who is an author of one of their AI and machine learning courses, gave a fun talk where he basically showed you how, step by step, you can take existing known good files and convert that into a data set of this is what a known good file looks like. And then you can train a machine learning algorithm to then process a bunch of files and then statistically calculate which one of these have abnormalities, because malware generally has some anomaly of some kind. So the use case he gave was you're given 100,000 files and you know one of them is bad, but how do you figure out which one? That could be your use case if you ever happen to run into that issue. The other big use case that you probably see the most of and is probably the most leveraged is actually for phishing and spam categorization. Every big email vendor in the world is doing some level of machine learning to try to identify and stop spam and phishing tickets or phishing emails. So very common, very good. I still get horrible phishing emails from time to time, but it's a lot less than when I was younger. A lot of the uh, a lot of the stuff I see now is at least a bit more sophisticated, fewer typos. So machine learning has helped us, hypothetically. While I was at Eastern Michigan University graduating, my senior thesis was actually on pretending to be a data scientist and doing some machine learning stuff. This is not day-to-day data analytics, but what I did was basically I took network traffic flow statistics. I did a packet capture of different applications running on a network. And then I used a tool that I'll talk about on the next slide to convert all of those into statistical summaries based on flows. So a flow in network traffic is anything that's using the same source IP, destination IP, protocol, source port, and destination port, creating statistical summaries of that. And it came up with something like 70 different properties, mathematical properties of stuff like maximum packet size, what was the inter-arrival time of packets. Some suspicious applications you might think of are if you have malware that has beaconing activity. It might not have data it might not have packets traversing every second. It might be significantly longer. Certainly more space between them than something like a live video stream. So I went and I collected all of this information. I used the tool NFStream to turn this packet capture information into flow-based statistical summaries using some of these fields that I'm talking about here. And end up with a fun result. We're going to go to this slide because I like the result more than the challenges. What I was able to do, and I used some very silly categories of network traffic, and data is hard. Getting perfect representations of data is hard. Basically, what you're seeing on the screen here is I had network traffic categories including Counter-Strike traffic, Discord call traffic, Half-Life 2 deathmatch traffic, Minecraft web traffic, Netflix traffic, Skype traffic, Vimeo traffic, general web browsing traffic, I called it, straight up YouTube, and a Zoom call. And this is something called a confusion matrix. And I tried a whole bundle of different machine learning classifiers to try to identify most accurately and effectively categorize network traffic based on these properties. And random forest, which is a type of classifier, proved to be the best. And what we have here is a confusion matrix, which tells us what was something classified as and what was it confused with. So this diagonal line going from upper left to lower right, the more green it is, the closer to yellow it is, the more accurate it was. Dark purple was not very successful. And then you can see things like, well, for some reason, if we look on the third row, this HL2 deathmatch traffic was only 55% accurate, but it was most often confused with that little square on the far left, which is Counter-Strike traffic. Why is that? Does that make sense? And you can talk about the viability of network traffic classification using machine learning, all this different types of stuff, issues with data, challenges you run into. I have a slide talking about some of the challenges you run into in a data analytics world when you're dealing with these kinds of things. So what you're trying to do with this sort of topic is meaningful you're trying to convert basically analog data into statistically usable data. And that could be hard. So consider, for example, I had a column that I was dealing with in this challenge, which was protocol, and it was actually a number. TCP, ICMP, and UDP are all represented by numbers in the RFCs. These numbers don't represent anything in terms of magnitude. They're completely categorical. They're what are called categorical variables. So when you run into these sorts of things, you have to be cognizant of that fact, and you have to deal with them before you train a machine learning classifier. So in this case, what you can do is that you can actually convert using a method called one-hot encoding. You can convert these different fields into their own columns that are basically on or off, depending on whether it is UDP, it is TCP, it is ICMP. So lots of fun challenges in the higher end data analytics space. A more usable use case that I think of when I think of machine learning is revealing relationships that you might not know exist. So when you train these machine learning classifiers, you can you can run one with a bunch of different variables and try to identify when does it perform best. And based on that, you can figure out what features are most important to a categorization. And if you do something like decision trees, which will literally try to make a decision tree for a classification, no matter how long, no matter how convoluted it is, you can identify relationships that are not immediately apparent. So in this example, on the decision tree on the right, what we see is this property called bidirectional minimum packet size for a traffic flow. If it was less than or equal to 217 bytes, this actually split the data up evenly in half. Why is that? And for a whole number of different problem types, you can identify, oh, I did not realize this property was so intrinsic to solving this problem, to making this determination, to making this classification. So I think this is an actually potentially useful use case that comes out of everyday, day-to-day machine learning stuff. Summing machine learning up, a lot of effort, not much everyday application. You require a lot of resource commitment. That is often too much for SMBs to maintain. And if you're thinking of doing machine learning for a really good use case like phishing or anti-spam, it's probable that vendors are already doing it and probably doing it better than you can. So it can be a fun exercise, but not fully helpful. And if you want to learn some machine learning stuff, the resources I use were this book, Practical Deep Learning, and a website called Kaggle. Kaggle is great for data science in general. So wrapping it all up, basic data analytic skills are essential for threat hunting. They make the impossible possible. Log management. We still haven't figured it out, even with data analytics, but it helps. And I think the biggest thing you can do with good data skills is be able to understand and tell a story from data that's happening in your environment. And with that, we have our thanks slide. And with any questions, we went for about 50 minutes. So not the most unbearable thing I've ever talked about. Any questions, thoughts, or concerns, fears, hopes, and dreams to share with the world? Ask what? Okay. I can't see the online. You're going to have to be their mouthpiece. There you go. Did anyone like the talk? There you go. Yeah.
What do you think?
That's the best possible outcome.
And then let's say that gardens would start to see a lot more than people did such a larger than just
Yeah.
whether that's the and that not the status big data.
Yeah, and sometimes we have to figure out how to do more with less data. So some people in the world have migrated to a cloud SIM. It turns out storage in the cloud is expensive. So you have to figure out how to use more with less data. And that's when you have to get creative and clever. So that's fun. Yeah.
Well, that's the normalization. Right.
Yeah. We'll find it.
Or there's somewhere. Let's still we find out that he threw downloaded TV. Why did
Oh no. That would probably be for the best. Here we go. Thanks, everybody. I'll do the outro. Thanks, everybody. Bye. Any announcements?
Only announcement we have is that MySecCon is currently scheduled for Friday, November 22nd, and tickets are on sale right now. You can get them at the early bird discount by going to myseccon.mysec.us. With that, we will conclude the stream and we will head on over to the social. So have a good evening, everybody. Woo!
Yay.